Some engineers employ a strategy called test-driven development. This is a coding practice where you invert the standard programming cycle. You write your test files before you write a single line of actual application code. There's a three-stage cadence to this known as the red-green refactor loop. The red phase is when you write a test checking for capability that does not exist yet. You run the test and you watch it fail. This proves your test is looking for the right thing and isn't giving any false positives. The green phase is where you write the absolute bare minimum code required to make that test pass. The refactor phase is cleaning up your implementation. If you have any duplicate code, you have to rename any variables or optimize for any edge cases. Then you can run your test suite again to confirm your optimizations didn't break any existing functionality. You continue this cycle, adding more tests that define more behavior, adding more code to make those tests pass, and then continuing to refactor and keep it clean and make sure all of the tests are passing before you add another one. One of the advantages to this approach is that it really helps you to think through what your code is supposed to be doing and define that carefully ahead of time. Unit tests are an excellent form of documentation for your code because they outline specifically all the ways that it is supposed to function. Let's take a look at this example where we are eventually going to have a function here called checkLevelUp. Right now it's just returning null, and the only reason I set it up this way is because I was already trying to import it and I just needed the signature to exist so it didn't throw an error. For the test, I've set up a describe block because there's multiple ways in which I plan to test the checkLevelUp method. Each of these individual tests currently are in the form of a to-do with just the description of what it is to be tested. We will fill these out one at a time and then write the code here that will make those tests pass. So let's start here. Our first goal is to have a function that returns true if a character has enough XP to level up. So I'll start by taking the .todo off so that we can run a test function and give it an anonymous function to execute when it's ready to run the test. I can create a character. And for our purposes, this is going to be an object that just has one piece of information so far, which is an XP of 120. Then we could say that the target XP, in order to level up, is 100. Now we write our assertion that we expect checkLevelUp and pass in our character and our target XP to be true. So we can run this, and now we see the red in our red-green refactor cycle. It's expecting true, it's receiving null. We're not surprised by this because we are employing test-driven development where we write the test before we write the code that makes it pass. So now let's take a look here and see what is the minimum thing that we could write here just to make sure that it passes. Instead of returning null, let's return the expression character.xp is greater than or equal to target XP. So as long as the character has at least enough XP to level up, this will return true. Otherwise, it should return false. Now let's run our test again, and we see that it passes. So we fulfilled our first goal of just returning true or false, whether they have enough. But let's say we also want this to go ahead and take care of leveling up the player and modifying their level number. Let's create another test that will check for that. We'll watch it fail, and then we can go back and refactor our function to make sure that both of these tests will pass. Let's set up our character with XP of exactly 100 and a level of 1. We'll set our target XP to 100 again. Now we already have an assertion that checks that if we call this function, it should return true under those circumstances. But we can still go and check the level up and pass in this so that we're acting on the method, and then write our assertions to check the value of XP and level. Let's say we expect that after somebody levels up, their XP should be 0 and their level should be 1 level higher than it was before. Let's run it. And it fails because we haven't written the code yet that will satisfy those goals. So let's go do that. We'll switch back over to where our code is. So now instead of returning this simple expression, we're going to need to specify a number of things based on this. So we'll say if character XP is greater than or equal to target XP, we'll eventually return true, or we'll return false. But before we do that, we need to modify the XP and the level. So we'll subtract the experience points that were spent, and then we'll also level up the character by 1 and then return true. So let's go back and run this test again. And now it passes. But we're not really done until we run both of the tests. So I'm going to run the entire file here. And we see that we're actually passing both tests. So that's the process of test-driven development, or TDD. You're going to get an opportunity to do this yourself over here in the practice. You'll have a function reduce damage that adjusts a player's damage based on the raw damage minus whatever value protects them because of their armor. And it's currently returning null. So you'll want to write the tests over here to make sure it works, and then go back and write the code that'll make the test pass. That's all I've got for you. I will see you in the next one.